the one question. So yeah, multiple choice and short answer. And okay, so number 4, pressure change when we decrease the area it is applied to by 75%. So remember, if we click back over here, pressure equals the force over the area. So if the initial, we'll say pressure is 1, force is 1, area is 1. So now if we go ahead and take and change it, so now our area is only down to obviously 75% of that. So we just take 1 divided by 0.25. So we figure it's going to be 4 times larger. Thank you. There are enough questions on the exam, Colton. I believe there's like 30 to 40. Yes, like I said, it's gonna be a short answer. So you can answer whatever you come up with, though do yourself a favor and obviously put your math in there so you can at least receive some partial credit. '18. We've already done 18. Here is 18. Well, the beginning of it. Okay. Number 3 and then number 5. Okay. Now, once again, let's come over here. 1,000 newtons of force, 2 seconds. Impulse equals the change in force over the change in time, or multiplied by the change in time. So it's 1,000 times 2, so it's 2,000. Okay. Work equals force times distance. So it's literally going to be 2,000 newtons times, notice it's 2 meters for 10 reps, meaning we're going to have gone 20 total meters altogether. So we're going to have a grand total of 4,000.
I thought it would be 400 meters.
200 times 20.
Oh, okay. Okay.
Yeah. Because notice it's 10 repetitions. Okay, 19. So we started on 18 before. So in order to get the vertical velocity, we first need to go ahead and do that sine 40 degrees, and then we're going to multiply that by 10 meters per second, and that will give us the vertical velocity. And then you're just going to take that vertical velocity we came up there, multiply it by 2, and then minus 1/2 times gravity times 2 squared. Angular motion in an athlete that's swimming forward. Well, where the arms legs, torso are all going to be turning, are we rotating? Yes. You have the individual and the group one. So you guys are gonna have to figure out what's gonna work from everybody's schedule so everybody works together. Okay, so force equals mass times acceleration. So now if gravity doubles, that means essentially acceleration is going to double. So your weight will double. Whereas here, no change, since mass is always going to be equal to the mass. That won't change.
So is there ever a time that mass changes?
Yeah,
Or
if we
never?
add to the mass of an object.
Okay.
Okay. Object is moving at 15 meters per second. How far will it gone in 5 seconds? Well, velocity equals 15. There's no acceleration affecting it, so the distance is simply going to be equal to 15 times 5. That's it. So 75 meters. No worries. So center of gravity is going to be where effectively we'd have the balance point between all the mass and an individual. So you're going from standing up to getting down into a 2-point stance. Well, it's going to lower. That's a big key. All right, so we need to get the normal force. So we need to take that 100 times 1.9 to get us the normal force. Okay. And now in order to get it to move, you're going to take that normal force, which is effectively 981, multiply it by 0.9. And that's going to equal the force needed to move the block. This is going to give us a direction and magnitude. So this is going to be equal to the initial velocity, which would be 15 times time And notice it's going to be deaccelerating, is going to be negative 1/2 times 2, because that's our deaccelerating. Oh, I'm sorry. We're looking at the velocity. That is completely wrong, because that one's going to be way easier than that. So instead, we're going to take 15, and this can be minus by 2 times 5. Because we're going to have, so effectively, it's going to be 5 meters per second. We have is our initial velocity, and then it's going to be plus the acceleration times time equals the current velocity. Okay, so first thing we're going to do is figure out our vertical velocity. And that's going to be equal to, we're going to use the sine of the angle, which is going to be 30, times 10 meters per second. And the good news is that's going to be 5 meters per second, because the sine of 30 is 0.5. So then our vertical distance is going to be equal to 5 times 2 minus 1/2 of 9.81 . 2 squared is 4. So one half of 4 is 2. 9.81 times 2 is going to be 19.62. So our distance is going to be negative 9.62 meters. So remember, anthrometrics are going to be weight, size, dimension, shape, etc. of an object, or of a person, of a limb, of a body, etc. Anytime, bud.
I was trying to do the lab, and I was using the app, the Metrometer, whatever thing, however you say it, and it was just, I didn't get it done because there's no excuse, but it was just all glitchy on the app. Maybe I downloaded the wrong app.
Okay, check the background that you're using. Make sure that you're appropriately spaced from it. And once again, I'm never expecting perfection, but the key is do your best, and obviously write in whatever values you come up with. And, you know, of course, look at them and think, are they realistic? So if it says that you've got, 360 degrees of motion in external rotation, like, no, that's not realistic. So you can look up normative values and kind of compare to that and see if any of that is sensible.
Okay, thank you.
No worries. Okay. Notice it says create to move a block. Okay, so that means between static and dynamic friction, which of the two are we going to use?
Dynamic?
Static. So notice it says to move the block.
Thought it was already moving.
We're going to use 0.9 because we're trying to get it moving. That's static friction. Whereas obviously here, in order to keep it moving, that's a different story. Because now we're going to multiply it by the dynamic friction. Yeah. Yeah, literally that's all. It's just 200 times 9.81. That's a big boy. Any other questions you guys want to work through?
Will this be put up on Blackboard, or we just have to watch it over on YouTube to figure out again?
Watch it on YouTube.
Okay.
Yeah. Fun fact for you guys, because, obviously I'm referring to those currently in the lecture, which I appreciate you guys coming. I can, oh, thank you, Josh. I can appreciate, it's easy to tell who shows up at the lecture because the questions I get from the students that are in lecture and the questions from the students that haven't watched the lecture are very different. Because the ones that show up here, you guys ask questions that are based upon the things that we're actually covering. But then the other ones I get are like, so how do we do the lab? I'm like, we went through this. Ah, you haven't watched the lecture. That makes sense now. I would be confused too.
I try to make it to every lecture, but I work Tuesdays.
All right. We're all doing our best to get through this wonderful pandemic. Also, pro tip, don't work out the same day you get the vaccine. I did that with the second dose, and yesterday was a rough day. But beats having the plague. All right, so let's round it out with 31 through 34. What answers you guys got for me?
$31, the statics.
Yep. Because remember, it's not just an object that's not moving, but one that is going to be obviously in constant motion. Yeah, great job, guys. Great job.
33 mechanics,
No, that's kinetics.
kinetics. Okay.
Great job, Anna, Kristen, and Marlana. Oh, fat fingers on a keyboard. So, I mean, that literally is every single question on the review. Obviously, things will be different, but the basic way that we set up the math to solve all of these. Myself. Yeah, so we covered it all. Cool. Anything else in general that we've covered over chapter 1 that you want me to go ahead and work through for you guys?
Can you scroll that down just so I can see your answer to what number 10 was real quick?
Yeah, no worries.
I was on Blackboard and I'm just looking at what students, so there's exam one, exam one group version, and then test one group take home section. So which one, so what is the test one group take home section?
Okay, so effectively the amount of math on each of those is going to increase. So the take home, that's the group, that is the math that you guys are going to be doing together. That's the stuff that's going to be a lot more involved, and you're not getting any multiple choice to help you. It's all short answers. So you've got to fill in the number. But obviously show your work. But the good news is only one person in each group needs to take that one. The first two iterations are mostly all just multiple choice. There's a couple short answer, but it's pretty much, like I said, mostly all multiple choice. And those are the ones where you're going to have only about an hour to take them. The take home group one, that one you have about 2 or 3 hours to answer all the questions. So that's gonna be one of those, figure out some type of obvious way to stream it, or not stream it, but for you guys to kind of work on it collaboratively. One person can try to share their screen, and then that can be the person that's answering it. Because on the group exams, you only need to have one person in each group taking them. There's a question where you write in, obviously, everybody in the group. Now, if it doesn't work out to take it with your group, then you obviously need to take it as an individual. And on top of that, make sure, obviously, you take each of those before the end of the due dates on Blackboard. If you don't take the exams before the end of the module or before the end, then you're just going to receive a 0 on it. And then that's that. So
Okay.
yeah, there's 3 different iterations of it. Obviously, the first 2 are the exact same. You just take it once and take it as a group. And then the second one is obviously going to be the one that's a lot more involved with the way the math goes. With the multiple choice, you can at least look at the answer that, or the 4 different answers that you're given, and then kind of work your way back is try to figure out, well, one of these has got to be right, so which one is it? Whereas on the math part, it's like, no, you're on your own. I give you some potential suggestions, but at the same time, you still need to figure out, a lot of those things on your own, and it's daunting.
And do you take all 3 of them and average them as your grade for the individual, or is it
No,
just
you get each of those grades.
Okay.
So that's how the exam is going to be worth effectively 200 points over the 3 different exams.
Okay.
Thank
you.
Yeah, there's a little bit of extra credit and otherwise, but each of them is worth about, in the 60s of points, upper 60s. But yeah, that's the key, is you got to make sure you take it from the model. You guys could take it today. You could take it tomorrow. The key is you can only take it until next Tuesday. If you don't take it before that time, then like I said, if anybody sends me an email and say, I'm sorry, I forgot to take the test within time, I'm like, that's okay. It made it very easy for me to grade. Because here's your grade. So I know I'm not saying this to the vast majority of you guys, but I'm sure I'm going to get one email at least. It's how it rolls. So also, if you guys get a chance today, go outside and look at the ice on the trees. It's actually very pretty. Though obviously it's pretty darn dangerous to walk around too much in the wonderful ice fields that we got going on right now.
My tree fell down last night.
Yeah, I took a very slow walk last night, so finally feeling good enough to move around some. Yes, most of them are due on Tuesday morning. I believe the group one is going to be due a little bit later than that. But the due dates are on Blackboard, so you have to make sure that you get it done before then. Any other questions on the exam before we're just going to do a little lecturing and move on to chapters 7 and 8. Yep. So let's talk about how we're going to analyze a sports skill. And this should also help a little bit when we're talking about obviously going through your movement and how those degrees and are going to change. So first thing we need to do is really look at what are the objectives of the skill. So are we trying to throw something? Are we trying to apply force? Do we need to be accurate, or do we just need to worry about distance? Okay. From there, we're going to look at any of the special characteristics. So is this a repetitive, meaning we're going to do this over and over again, like long distance running, like swimming, skiing, etc. Or is this non-repetitive? So we have a beginning and we have an end. This could be pitching a baseball, throwing a shot put. This could be jumping. This could be a gymnastics routine. This is where you're going to see obviously a start and a stop. Then, is the skill we're looking at going to be predictable or unpredictable? So predictable meaning it's going to be the exact same thing every single time. So as far as, throwing the javelin, throwing the shot put, doing the 100-meter sprint, etc. Yeah, the weather can change a little bit, but it's essentially the same thing over and over again. Whereas a lot of sports that, let's be honest, most people are more interested in are the unpredictable, meaning this is where we have an opponent that we have to overcome, and they're going to obviously try to react to whatever we're doing, or we have to react to what they're doing, and that's going to make things different. So when we're talking about, trying to steal a basketball from somebody that's dribbling, when we're talking about trying to tackle somebody in football, when we're talking about having to box someone, wrestle someone, etc., obviously that person has their own goals, and that involves not being hit in the face. So because of that, we have to now not just do these skills, but we have to be able to rapidly adapt them to whatever specific demands we're having, given the conditions that we happen to be currently encountering. Now, from there, we want to look at really, really high levels of the skill. So how do the best do it? What is the general overall speed of the movement, the rhythm, the timing of the different parts of the body when they're doing it? Think about watching a little kid throw a baseball or a softball compared to watching a high-level pitcher throw a baseball. You're going to see obviously a lot more refined technique, a lot more efficient timing. So they're going to get that maximal velocity. And so think about what are the mechanics, what's going on when we're really trying to break down those biomechanics of the forces being produced and absorbed by the different joints as they go through that range of motion. Now, once there, we divide the skill into 4 separate phases. The first phase being the preparatory movement. So this is in the mental set. So this is getting set up. So if we're talking about a baseball pitcher, this is going to be literally getting into the windup or the stretch position. Now, then we have the windup itself. This is going to be the backswing. If we're talking about a vertical jump, this is going to be the dip when you're going into the bottom of the drop before you're going to go ahead and jump as high as you can. Then you have the force producing. So that's going to be where you've finished the windup and now you're trying to throw the ball as hard as you can. Now, as soon as you release that ball, you then have the follow through. So letting the arm come through, letting the shoulder come through, letting the body come forward. So obviously different activities are going to have different ways that we're going about this. So if you're swinging a baseball bat, the preparatory motion is just getting set with the bat, getting in your position. The windup is going to be that little bit of cocking back, and it might not even truly exist, but you're going to have maybe a little bit of rocking of the leg. Then you're going to have the force producing of swinging the bat until they hit the ball or obviously miss. And then we have the follow through after they go ahead and swing at the ball and we move on through. So more examples of how we're going through the preparation. So getting set in your stance. And then obviously if it's a repetitive skill, you just do this once. So this is getting set in the block for that sprinter, swimmer, etc. Now, then we have the windup itself. So how we're going to go and have that initial backswing before we're going to go ahead and then follow through where we're producing that force, making ourselves actually do the movement. And then finally, after we go ahead and do the active force producing, so we've either hit the object or released the object, this is where we're going to have the follow through. Now, this is something because we want to follow through, because if you try to stop yourself the second after you release all that force, you're going to be doing a lot of potential eccentric damage on your joints. And that is obviously not the goal of things you want to go ahead and do. And by dividing it into all of these different phases, we then can figure out what are the key elements in each of those phases. So if we're looking at someone in golf, is that we're going to see the body weight shift from the rear foot to the front foot. We're going to see the hips rotate as they're driving, and we're going to see the arms extend when the club is going to come into contact with the ball. And by understanding this, we're going to in turn be able to give information when we're coaching an athlete as to what's going on, what they're maybe making a mistake with, what they need to go ahead and work on. So from there, we can obviously go ahead and give them a bit more of a education on what needs to be improved, what needs to be adapted. So now we're going to go ahead and have you guys get into your wonderful groups. So do me a favor, guys, in the chat, just go ahead and post up what is your group. And I'm going to manually create the breakout rooms so that we have got each of you guys in a group with your individuals. Guys, you probably mean forehand in tennis. I don't think there is the forearm in tennis. Okay. Sorry, guys, I'm making sure that I got all this right because I'm not sure if I did it correctly. Okay. Now with the clean and jerk group, guys, you probably are actually going to have technically two different movements in there. Actually, have the clean and the jerk. So make sure that you go ahead and break those down appropriately. But let's give you guys about 5-10 minutes to really think about breaking down each phase of your movement, what's going on with each of specifically your joints as we're going through. I've just opened the breakout room. I do have a couple folks that are unassigned because I don't know if they've commented yet, or maybe I missed your comment. So obviously go ahead and help me know where you should go whenever you guys get a chance. Cool. Okay. So you guys were able to figure out what you guys were doing during each of the phases for your given exercise. It's okay, Haley. It's okay. Yeah. So now the key is obviously, you know, the basic way the joints are going to move. So now the question is, how many degrees are those joints going to move through in each of those phases? So that's the part that you guys are going to be doing, obviously, in the anthropometrics lab, if you haven't already done it. Do we have any more questions there of anything you guys want to go ahead and work your way through? So the next brief little presentation we have, which is now that we've had a good way of thinking through the different phases of a movement, now let's go ahead and talk about how we're going to go ahead and remedy any mistakes that occur whenever they're going through those movements. So the first thing we want to do is obviously observe the movement and observe it from a number of different positions. So we want to see it not just from the front, but from the side, and if we could even go overhead, even better. And then typically we want to have them do the skill multiple times, because then you get an idea of, is the skill, are they making the same fault every time? So we really do have an issue with the movement, or do they make a different fault each time, which is telling you that they don't really fully understand how to do that skill yet. So we just need more practice and still give them, you know, clarity on what they need to work on, but understanding that really specific advice doesn't work because they're not making any specific mistake over and over again. Now, the number one thing always, whenever we're doing any advice for a technique, is going to be ensuring safety. Now, this is not just for you, but obviously the athlete. We want to make sure that they're not being distracted. We're not going to be making comments. We're just trying to effectively allow them to do the movement and see what's going on. Now, we don't want them to try to go slower, because when you go slower, it's easier to typically do things right. We want them to do the speed they're going to actually do it with. And once again, more angles. And that's actually what you guys will be doing with your projects. Now, we want to look at other cues. So they're auditory cues, are the results, and then how did the participants feel? So there's certain skills that are naturally going to feel awkward. So kind of the positions and certain things like Olympic lifting and otherwise, certain things are going to feel awkward, but doing them correctly actually does feel a little awkward. Doing a backflip is going to feel really weird because you're literally flipping yourself over yourself. And that's something that obviously most human beings are trying to never do, but they still need to have that type of feeling for it. Now, you can do things a little differently, but if you get the results you're looking for, well, for performance, you're doing fine, but long-term performance, if we're doing something with technique that's detrimental to the athlete, it turns out they're gonna be more likely to be injured, and then we're gonna have some issues. Now, obviously, when it comes to auditory, think about the sound that a ball makes whenever a baseball or a softball makes whenever the bat hits it, when it hits it well, as opposed to when it's hit off the handle or otherwise. So sometimes you actually have the sound of the objects where you're like, oh, damn, like that one, that was a really good one. And then same thing if you're talking about someone being punched in the sport of boxing or otherwise, but when you actually hear the person get hit, then you're like, oh, that's bad. Because like anything else, it gives you an indicator of the forces that were effectively encountered. So when we say pick a good location, think about not just the lighting, but also think about the background. So if you have someone that's wearing all maroon and there's a maroon background behind you, you're not going to be able to really see it too well. So you want to see there's a contrast. Like they could be wearing dark clothing with a white background or vice versa. So that way you're going to have that better contrast of what's going on. And also, you typically want to go with more tight fitting clothing because that's going to give you a much better idea of where the body's at and how they're moving, as opposed to if it's really baggy clothing, it's going to kind of float around them and you're not going to really be able to tell where they happen to be at inside of that space. So then we're going to break down all of those phases. We can either go from the result and work backwards, or we can go from the start and then work forward. I suggest going from the start and work forward and seeing where they make their errors, because obviously they can sometimes make corrections at the very end. They're going to do the correct thing, so to speak. But if we would just have them start off correctly, they're going to be less likely to injure themselves. They're going to be able to perform at a higher level. So remember the thing about throwing. So prep is getting set, windup is going to go and pull back, force producing is going forward, and then follow through is from the release on through. So we want to think about, as we're going through each of those stages, of is the athlete effectively approaching the movement with the appropriate amount of stability when they're applying or receiving the force. Now, obviously, some sports like throwing a discus, a shot put, there's a rotational component. So yeah, they're going to be obviously unstable for parts of it. And like anything else, that's going to be problematic. And that as they're unstable, they're going to be more likely to make mistakes, but we want to go ahead and watch and give them feedback. Now, are they going ahead and moving their base of support towards where it's going to be? So if I'm pitching, I'm going straight down the mound towards the plate, or am I falling off in one direction or the other? Now, is the base too narrow, so we're almost like trying to stand like we're on a balance beam, or is it too wide and that we've got our feet too far apart, we're not going to be able to do things appropriately? Are we too upright where we should be squatted down, or are we too low when we should be up high? And like anything else, is our center of gravity too far to one side or the other, so we're not going to go ahead and be in that center line where we should be in order to have optimal stability? Now, from there, let's go ahead and figure out what errors we want to correct. So the first one we want to go with are the big major errors. So this is something that is biomechanically incorrect. So this is something wrong with their mechanics that actually is going to increase the risk of injury. From there, we're going to go for those minor errors. So the little tweaks that are going to help them perform better, but aren't going to be like a legitimate risk factor for them to go ahead and injure themselves. So for example, in the clean and jerk group, lifting with a rounded back, that is going to be a major error. That is going to be something we want to go ahead and work on immediately. Now, a minor error could be something as simple as they're not driving their head through whenever they get to the jerk. Instead, they're looking up at the bar at the very top. That's a pretty simple fix. But if they're trying to lift like they're a dog using the bathroom on the lawn, that's more of the problem that's actually going to injure your athlete. And so from there, we need to think about what's an appropriate way to go ahead and correct that problem. So obviously, giving them information that the athlete can process and apply. Anyone can bark orders at somebody, but that doesn't mean they're going to understand what you're saying. That doesn't mean they're going to be able to implement the information you're giving them in a meaningful way to actually affect change. So we don't want to start off by giving 47 different comments about all the little technical faults they had in movement. Instead, give them something positive they did correctly. And sometimes it could be, you tried hard, as bad as that sounds, but sometimes that's what you're dealing with. And then, okay, let's give them one, maybe two major things to work on, because most people aren't really good at holding more than one thought in their mind at a time. So trying to give them 2, 5, 8, 30 different pieces of advice, you're just going to confuse them. You're going to overload them. It's not going to work. Instead, just give them one thing to focus on and make sure that one thing is the important thing to start off with. And then slowly, once they get that correctly, move on to the next one, because we want to, again, keep the athletes safe. So for you guys in your groups, as you guys obviously had a chance to talk today a little bit, is we want you guys obviously to go ahead and video what you're doing with your movements. Now, obviously, now that our phones have cameras in them, you can go ahead and just use that. Now, the key is we want there to be a video from the front, a video from the side, and then a video from overhead. So my advice for most of those groups is go over to the campus rec center. The track overlooks the basketball court. You're going to be able to get the video from each of those angles. Now, you're going to obviously have someone doing this that is an expert and someone that's doing these movements that is a novice. You're going to go ahead and make sure that you're videoing this appropriately. Now, nice. I like how a number of these points are antiquated. Like, use a tripod. Yeah, if you have one, that's fine. Otherwise, guys, just be as steady cam as you can with it. We want to make sure that we're obviously doing things straight up and down. We're not doing things in an angle. We want to make sure that we're far enough away that we can see the entire movement, but not so far away that we can't get a lot of good information. And then we can obviously see what's going on with the projectile if they have to hit one. We want to make sure that they're in the center of the movement, and specifically, we're going to get all of the body doing the movement. And if anything, getting our shutter speed to be as quick as possible, and obviously record on your phone. You've got your time, date, and even your location. So that way you've got that information as to where things are going. So relatively simple stuff, but important components to keep in mind when you're working with athletes to make sure that you're going to go ahead and give them good advice so they're going to be able to perform well. Now, the last things we're going to do, because I'm going to let you guys go early today, because you've got an exam on Tuesday of next week, and exams technically where you need to get all 3 of those done. Now, do your best on them. Make sure you think through all your questions. You can backtrack, but make sure you're really taking your time, thinking things through, and doing your best on each of the questions on each of the exams. Now, for the short answers, guys, I will give partial credit. So try to write in, here's the formula that I used, here's the math steps I used. So literally, if you just made the mistake of like an order of operations error, or you didn't put in the right values, but you set everything up correctly, you'll still get a pretty decent amount of the credit. If you didn't write in anything other than an answer and the answer is wrong, then you're going to get 0 points, because, okay, you tried to answer it, it was wrong. I've got no other information. I don't know if you set up everything correctly and then made a mistake, or if you're like, whatever, YOLO. So make sure that you guys are going to go ahead and still kind of write in the work that you guys are doing as you go through it. Now, the other thing is, since the exam is on, or everything needs to be due through Tuesday, we will not meet on Tuesday of next week. So you guys can do this at your own leisure. Once again, be mindful of the due date. Make sure you guys start that, and you guys get yourself up or set up in such a way that you don't have to worry about your internet connection dropping, or otherwise you've got some redundancy, meaning you can use your phone's Wi-Fi and your home Wi-Fi, or your phone's cellular network and your home Wi-Fi, or go to the library on campus if it's nearby, something where you've got a backup plan in case anything goes wrong. And obviously talk amongst your group to figure out what's going to be a good time for you guys to go ahead and get together to take the group exams together. If you are not able to do so, obviously you still take it as an individual. Now, the other thing about those group exams in the individual, if anyone in your group takes their individual exam after the group took the group exam, they're going to receive a 0 on their individual exam. So if you say that you took it with your group, and I can see the timestamp, which you can in Blackboard, that you took your individual exam after the group exam was taken, congratulations, you've now received a 0 on your individual exam. So that's pretty much the only hardball that I needed to make sure that I got out there for you guys. Otherwise, stay safe out there, guys. Enjoy the ice, I guess. And are there any questions, comments, concerns before we wrap it up for the day? All right, well, since there's no questions that I'm seeing, stay safe out there, guys. good work today. Study hard, and I will see you guys on Thursday of next week. So, bye-bye.